welcome back, and a lot has happened in the last 7 days. I somehow managed to lose my beard, completely wreck my voice, destroy about 15 vacuum tubes, and attend one of the coolest events I've been to in a long time. Shortly after I finished the last episode, I got into a mad dash to try and get everything prepared for a VCF Southwest event coming up in Dallas. It's been a long time since there's been a VCF here in Texas, I think about 10 years, so it was really exciting to finally have one close. But I knew that if it was only 2 hours away, I had to go hard. So I got to work preparing the Mini Centurion, the PDP-1183, the Wang Rider, and the vacuum tube computer. I managed to get it all stuffed into our truck, drove the 2 hours north to Dallas. On Friday, we got in nice and early, set everything up, got my booth set up, and I was going, yeah, man, I went hard. I brought a bunch of stuff. And then I looked around at the caliber of other exhibits on display there, and I realized I was 100% amateur hour. There was some phenomenal stuff showing up. A good friend of mine, Commodore Z, came down from up north, and he brought an unbelievable VIC-20 display. Right next to me, I had Forgotten Machines, and AJ brought out some of the coolest stuff I've ever seen. I mean, he's got some stuff that there's only like 3 or 4 of known to exist in the world. So when we're saying rare, this guy is killing it. There was some computer guy brought some really neat stuff. That sounds confusing. Some computer guy is his username. So I'm not just talking about a random person. Some computer guy brought some really cool stuff. He had an IBM Punch, an ASR. My good friend David brought some very cool IBM kit and an HP plotter that was an absolute joy to see work in person. And one of my personal favorites of the show was Nicola Wan brought a Tektronix 4054A that had a 19-inch storage CRT and drew everything in vector lines. And that is just a tiny snapshot of all of the unbelievable machines that were on display there. And I actually didn't get too many pictures of the event. I was too busy talking to everybody and hearing their stories and just having a blast. But all of the pictures that I've been showing up to this point are from various photo albums that people have posted, and I'll put a link in the description below to all the photo albums that I've come across so far, so you guys can go through and take a look at all of the glorious machines that were at this event. But we got into Saturday, and between noon and 2 on Saturday, there was a YouTuber/streamers talk, and we had some really very awesome people on stage. We had Taylor and Amy from the Taylor and Amy Show, David Beam from the IBM Museum, Mark from Curiousmarc, yes, the Curiousmarc, and Jeri Ellsworth, yes, the Jeri Ellsworth. We had June from Nybbles and Bytes, little old me, and we had Sean from Action Retro, and David Murray from the 8-Bit Guy, and it was all moderated by the extremely capable Bill Hurd. It was an absolute honor to share the stage with these people. I was totally starstruck, and they had a wealth of good information and insights and stories to share. So definitely go check out each and every one of their YouTube channels. I'll put links in the descriptions below because they're all just so brilliant and were so much fun to talk to. Also, you can watch the entire talk for yourself right here on YouTube at VCF Southwest's own YouTube page. Again, I'll put a link in the description below. Check out the talk. It's 2 hours long, but it's absolutely worth the watch because it was just a total riot. It was so much fun. But after the talk, we got back into the show, and I was just having the time of my life, showing people the Centurion, letting them get hands-on with it, or the Wang Rider, or the PDP-11. And well, you know, the machines weren't without their fraught. The Wang Rider absolutely refuses to print anything. It keeps chewing up ribbons, and the vacuum tube computer was being extremely temperamental. And well, we'll get into all of the problems that we're having with this machine a little later. But as Saturday wound down to the end of the day, there was an awards ceremony. And there was a lot of really awesome awards going around. and they finally got to Best in Show, and somehow I ended up with the award for Best in Show. Given the caliber of machines, the caliber of people at this event, it's just extremely flattering, and I almost don't feel like I deserve it. But thank you guys so much. And well, above this, I want to thank everybody that spent many sleepless nights to get this event going. Raymond, Jay, there's so many names that I can't name them all, but all of you, the combined effort, y'all slayed it. It was an absolutely amazing event, every bit as good as VCF East, and I can't wait until next year so that I can bring some more interesting and cool stuff. But at the beginning of this quite long intro, I said that I somehow managed to destroy about 15 vacuum tubes, and well, thankfully that didn't happen at the event. Everybody was really mindful of the vacuum tube computer and there was zero damage. But after the event, when I was loading it up into the truck, I set it up on its kickstand and walked around to open some doors, and as I turned back around to grab the machine, the wind caught it and picked it up and toppled it over. I dove for it, but I was just a fraction of a second too late, and it hit quite hard on this top corner here, and then toppled over and hit over here, and the damage was severe. Well, not too severe. Like I said, we only destroyed, I think, about 15 vacuum tubes. We did bend up a couple of connectors, and as it sits right here, it is well and truly dead. But it is not unsavable. And I am not going to be able to sleep well at night until we get this machine back up and running. So that's what we're going to do today. We're going to pull this off the wall, set it down, take a look at the damage, fix it, get it back up working tip-top, and that way we can be ready for the next parts coming in this series. So let's get to work restoring our broken machine. Now that we've got it laid out flat on the table here, this is the first time that I've really taken an in-depth look at the damage that was caused, and it's pretty gnarly. The two 2D21s here at the top got absolutely flattened. There is no more glass there, and they got bent over and pushed into the relays. Then the top D flip-flop here for our instruction register, all but one tube absolutely just got hammered. The D flip-flop below that has a couple of dead tubes on it as well, and there's just tubes that went to air scattered throughout the entire machine. And surprisingly, a lot of tubes got bent but didn't break. That is phenomenal. We've got some that are bent almost at a 45-degree angle out of the socket, but the getter hasn't gone white and they still look good. So I might be able to pull those out and straighten the pins. Now, replacing tubes on here is not a big worry. These are all 6AU6s, and I have about 2,000 of these. This board only uses 190, so I could replace every single 6AU6 on here and still have plenty left over. All of the little VFD indicators seem to have survived, so that is a small saving grace because those are actually pretty rare. The biggest worry, though, is that some of the board-to-board connectors got bent pretty heavily. We can see up here by the D flip-flop, there's a couple of connectors that got all sorts of twisted up. And then down here, the buffer and indicator board for the result register and carry register got pushed almost completely out. So there's a bunch of little connectors that we're going to have to go through and straighten out, which means we're going to have to take quite a few boards off of the backing plate, fix them up, then screw it all back together. But I don't see anything on here that looks catastrophic, completely unsavable. I think we can get this thing fixed pretty easily. Let's start by removing all the bad tubes. The 2D21s were tough because the bases were broken and they required something to pry with. But with those two removed, let's move on to getting all of the tubes off of the D flip-flop that got hit the hardest. Some of these are broken clean in half, and this last one also had a broken base, which required some needle nose pliers to get all the pins out of the socket. It was pretty gnarly stuff, but after that we'll remove the two buffer tubes next to it. Then we'll go get the two tubes that went to air on the next D flip-flop down, followed by this one on the decoder board, and thankfully the white getters that show it went to air make it really easy to identify bad tubes. And next we'll focus on getting out all the tubes that have bent pins, and there are considerably more of these than tubes that went to air, which I find really interesting. It goes to show just how tough vacuum tubes really are. These all got jostled around and maybe even struck the pavement, and yet they all look like they're still holding good vacuum with no cracks or breaks in the glass. It's really impressive stuff. As best as I can tell, this is the extent of the damage to the tubes. We have 14 tubes that are broken and went to air, with the exception of this one right here. The getter still looks good on it, but the evacuation nipple is very clearly broken. So it probably still has a seal, but I'm not going to risk it and just toss it in with the broken tubes. And then all of these up here, there are 24 of them. These all have bent pins, but the glass is not broken and the getters are good. So these can probably just have the pins meticulously straightened with a pair of pliers, and they'll be totally fine to go back into the system. We still have to fix a bunch of the connectors, but all in all, I think we got off pretty light for this thing getting completely toppled over in the wind. Next, let's get all the boards with bent connectors out. Starting on the edge and working in, we removed the relevant screws, and the first side piece pulls right out. Then the next piece in that got hit the hardest pulls right out after that. There's no screws holding it in place. Then we'll get the results register and the carry register out next, and then finally the inverter board behind them can come out. On the top corner, we'll remove the connectors, followed by the screws for the skip control board. Then it just pops right out, and the connectors on it are relatively straight, thankfully. Next, all 4 D flip-flops for the instruction register have to come out, and with the screws removed, they slide out with ease one by one. This lets us get access to the buffer board and remove it, which also got hit really hard bending up the connectors. Finally, the soft start was misbehaving all weekend, so let's get it out for troubleshooting. There's quite a few screws holding it in place, but with those out of the way, the entire thing lifts right out. And looking at what's left, you can really see where it hit the ground, taking out a corner and a section midway down, but leaving the rest relatively untouched. And these are all the boards that are going to need work. With them removed, you can really see how bent the board-to-board connectors are. But aside from the connectors, the only PCB damage is this light scuffing on the very edge. To get the female connectors back in shape, I'll just bend them in place by hand, and to get the male connectors back, I'll use needle nose pliers, which actually is really hard to do with the camera blocking my view. I'll have to do these off camera. And well, there we go. Good engagement again with the board-to-board connectors. I think this is going to work. And so with all the connectors now straightened, we'll go ahead and start plugging boards back into each other to make sure that everything all fits well. Then it's time to start repopulating these boards with tubes, and I want to reuse as many of the tubes with bent pins as possible. So it's time to get some background music going and just sit down with a pair of needle nose pliers and meticulously go through and straighten each pin one by one. 24 tubes with bent pins that each have 7 pins means that we have 168 total pins that need straightening. This definitely took a little while, but once all straightened up, they popped right back into their sockets like new. Nice affirmative engagement with the pins and good alignment. These little Harwin 1mm PCB pin headers work great as sockets and are surprisingly tough. Next, we'll bring the main board back over so we can start populating all the sockets that had bent tubes on the boards that we didn't remove. We're getting pretty close now, so let's get the now repaired boards back in place, cinching them down nice and tight with their mounting screws. Then we'll get the bus and power connectors back in place, and finally let's get the entire instruction register back on in one go. The clearance between the tube and mounting screw on these D flip-flops is quite tight, so the screw actually needs to go in first. Okay, we're almost ready to put some power into the whole thing and see how it goes, But I need to troubleshoot the soft start here first. The way this soft start is set up is that for 24 volts, when you first flip the power switch on, the power goes through this 0.8 ohm current limiting resistor. Then once the Thyratron here warms up, the relay clicks over and shunts across this, so you have a direct connection from 24 volts to all the filaments. That just kind of limits the amount of initial inrush current into the filaments. And we do the same for negative 12 volts, only we do it with a 2 ohm resistor. And we can actually check that pretty easily with our multimeter here. If I go from the negative 12 volt input here over to this side of the current limiting resistor, we can see we have a direct connection. And if I go to the other side of the current limiting resistor, we can see, there we go. We've got 2 ohms. That's exactly how it should be. Now, if we do the same for 24 volts here, if we go to this side of the current limiting resistor, we've got 0.1 ohms, essentially a direct connection. And then if I go to the other side, we have an open connection. This current limiting resistor has gone completely open. That's why the soft start was having trouble all weekend. There is no shunt going on here, or there's no current limiting going on. So when the shunt tries to kick over the first time, it's just sending a massive amount of inrush, and then the soft start resets and the whole thing gets very upset. So we need to replace this 0.8 ohm current limiting resistor, but I don't have a spare one of these. So I'm just gonna have to steal the 1 ohm current limiting resistors off of the soft start for the other board that we were building. This is not too big of a deal. This soft start was a bad design and I needed to cannibalize all the parts off of it anyways. So I've got the soldering iron warming up, and this should hopefully be a pretty easy fix. The resistor is held in place with 2 screws. I'll just go ahead and remove those. Then I'll heat up the wire with soldering iron and remove it from the resistor, and allow me to remove the resistor from the board. And then next, let's start cannibalizing parts from the other soft start, starting with the 2D21s. We'll then desolder the 1 ohm resistor and set it in place on the soft start that we're trying to repair. We'll cinch down the screws, locking it in place, and solder on the wires. Then we'll pop in the 2D21 Thyratrons into their sockets. And now it's time to reinstall the soft start onto the backing board. After locking it in place, it's ready for a test. All right, moment of truth. I've got the lights off so I can hopefully see all of the filament strings come up. That'll let me know if I still have some intermittent or bad connections anywhere. I also have the air conditioner running because if this does actually work, this thing is going to churn out some heat. So what we're hoping to see is an initial spike of current on both of the ammeters here, and then as that kind of dwindles down, the Thyratrons will flip off and we'll see a second spike of current, and then it'll all settle in, and then hopefully we can start running some operations. So here goes nothing. First power up since the crash. We saw our first spike. That's good news. That's going to start dwindling down. The Thyratrons are warming up. I can see them glowing up there. One relay kicked off. The other relay kicked off. That's really interesting. Why did it take so long for the second relay to kick off? But it looks like everything's warming up. I don't see any smoke. I do see some VFDs on. Let's see if we can initialize it. We'll just try to get a NOP-O into it. Yeah, that worked. So that reset all of my instructions. So let's do a 1010, force the data bus to 1. That turned IEN on, 1011. That turned OEN on. Then we'll do a 0100. That should get a 1 into our data bus. It did, but it did not turn off our carry register. Oh, that's interesting. All right, so let's do a 001, see if we can load a 0. We can load a 0. Let's add a 0, see if that turns my carry register off. No. So we do have a fault. I can't seem to clear my carry register up here. And looking at it, these 4 tubes don't seem to be warming up. So looks like we have a problem on our carry register. Let me fix that right quick. All right, I think I've got the carry register going. Turns out we just had another bad tube in there. The getter did not go white on this one, but perhaps the violence of the crash caused the filament inside to break. But once I replaced this tube, that carry register came alive and I was able to clear it and drop the 1 from the carry register into the result register. And I believe the entire thing right now is warmed up and ready to go. So let's just do 1 + 1 = 2 to test it out. And so to do 1 + 1 = 2, we'll do an instruction of 0, 0, 0, 1. We'll force the data bus to 1. This will load a 1 into the result register. I can see that it did that. We will add that with a 1. We just did our 1 + 1 = 2. That gave us an answer of 1, 0. So the result register is now currently storing a 0. The carry register is storing a 1. Let's output that onto the data bus and get the right pin illuminated. We should see all that on the remote up here, but we should also see the flags kick on down here. And yep, the data bus is storing a 0 because there's nothing in the result register, but the right pin did kick off, so that is good news. Then we'll do a 0, 0, 1, 0. That is an add instruction. With the data bus at 0, this should drop the carry register into the result register, and it does. Then we'll do a 1000 again, and now the data bus has a 1 on it. The right pin is on. We just did 1 + 1 = 2. I am going to go out on a limb and say that the entire thing is working. There's a total of 16 instructions that I do need to sit down and check just to make sure that everything is working fine. But the fact that it can do addition and output the results of that onto the data bus tells us that a large majority of the system is up and going. I'm going to call that a win. There we go, all repaired and looking beautiful and ready for the next event where hopefully I won't topple it over into the ground and let it crash and smash a bunch of tubes. Accidents happen. I'm sure I'm not the first person to break something going to or from an event, and I'm sure I won't be the last. But to quote the great Rocky Balboa, it's not about how hard you hit, it's about how hard you can get hit and keep moving forward. And we got hit pretty hard, but well, we're not going to let something like that stop us. And we got to work and got it right back up and going. And I am very much so amped up about this project moving forward. And well, I'm very amped up about next year's VCF Southwest. I had an absolute blast this year, and I cannot wait for next year's. And I think 1 year might just be enough time to finish off the entire second half of this system. So hopefully, if everything goes very smoothly, we'll have this at next year's VCFW with a full-on paper tape unit next to it, executing programs in real time. So that's something to look forward to. I got a lot of work ahead of me, so I'm gonna start planning, cutting some more circuit boards, and well, getting to work. So I wanna thank you guys so much for watching, and I hope to see you next time.